Let's take a look at a couple of these examples. We have an arithmetic series with the first term negative 32, minus 28, minus 24. Again, similar to what we've done before, let's list off the things that we know. We know that term 1 is negative 32. The common difference from negative 32 to negative 28 looks like 4. Negative 28 to negative 24, also 4. So we seem to be gaining 4 as a common difference. We are looking for sum 14, and we know that n is 14. Which of our two formulas has t1, d, and n? Looks like the second one. We don't have the last term. So let's try this formula out. Sum 14 is going to be n, which is 14 over 2. 2 times negative 32 plus a common difference of 4 and 14 minus 1. So that's 7. So 4 by 13 is 52. 7 by negative 64 plus 52, so we get 12 negative style, and multiplying that by 7, it looks like we get the sum of the first 14 terms is negative 84. So a pretty simple application of the formula that we're given. What I'd like you to try and do is use the formula in this next example to find the first term. So let's write this out maybe again. T1 we don't know, that's what we're solving for. S17 is 34, T17 is negative 22, D is negative 3, and we already know that it's the 17 terms. So why don't you take a second, hit pause, and try that question. First formula looks like is what we're going to use. Let's go with sum of the first 17 terms is 17 over 2, term 1 which we don't know, and negative 22 is the final 17th term. So what we can do is we can hit 34 times 2, move that 2 up, gives us 68, divided by 17, and adding 22 we get 26 is the first term. So a lot of times with these questions what we're going to see is the first part carries on to the second part. So very similar information. We're looking for the sum of the first 9 terms. N is 9, common difference in the same series is negative 3, and in this case T1 is 26. Why don't you give that one a try as well. Sum of the first 9 terms, we don't have the 9th term, so we're going to have to use the second formula. N over 2, 2 times term 1, plus dn minus 1. So let's go negative 3, 9 minus 1. And over 2 times 28. Let's try that out. 28 times 9 divided by 2, and we get 126 for sum 9. So pretty straightforward application of the formulas. Let's see what this looks like maybe in a word problem. Students build a trapezoid structure out of cups. On the bottom row there are 10 cups, and each successive row above has 2 less cups. How many cups in total are there in the structure if there are 5 rows in total? I do like the idea of picking off here some information. Bottom row has 10. Successive row has 2 less cups. How many cups in total? So that's an important term as well. and we're talking about 5 rows. So each of these things we could pick off. On the bottom row there are 10 cups. Each successive row has 2 less cups. How many cups in total means we're looking for a sum if there are 5 rows. Again, we don't know the final term 5. Certainly we could just add this up by hand. That's nothing wrong with that. If the numbers work out for you, great. Let's go to the formula maybe. The sum of the first 5 is n over 2. 2 times term 1 plus the common difference of negative 2, 5 minus 1. So we have 5 halves times 12, which is 30. So there's 30 cups in total. This ends the examples for arithmetic series.